Physics, May-June 2014, Paper 12, Part 2. Question 11. The graph shows the variation with time of the speed of a raindrop falling vertically through air. Which statement is correct? Now this is a graph which tells the speed-time graph of a raindrop falling in air. First thing, let's see. At time t is equal to 0, when it's falling from the maximum height, the velocity will be 0. But at that time, the acceleration will be maximum, that is the acceleration due to gravity. So the resultant force is just the weight. Now, as time increases, the speed is going to increase. In other words, when speed increases, air resistance also increases. As a result, the resultant force is going to be the weight minus air resistance, which means the resultant force is decreasing. As a result, acceleration will decrease. At one point, let's call this as t, what happens is your weight will be balanced by the air resistance. In that case, the downward weight is balanced by the upward air resistance. So resultant force is 0. Therefore, acceleration is 0. The speed remains constant. And this speed is known as terminal speed or terminal velocity. Now you can observe from this graph, it's a speed time graph. So the gradient of speed time graph will give you the acceleration. As you can see, from maximum acceleration initially, it reduces to acceleration 0. So the acceleration is decreasing. Now here we have to choose the correct statement. Option A, the acceleration decreases to produce a steady speed. So the steady speed is what I told as terminal velocity. So this statement is correct. But let's go and check the remaining option. The acceleration increases as the speed increases. No, as you know, the acceleration is actually decreasing. The air resistance decreases as the speed increases. As we have seen, when speed increases, air resistance also increases. So this statement is incorrect. The resultant force increases as the speed decreases. As you can see, the resultant force is decreasing, and at terminal velocity, the resultant force is 0, which means this is also incorrect. The correct answer for this question is option A. Question 12. A tiny oil droplet with mass 6.9 into 10 to the power minus 13 kg is at rest in an electric field of electric field strength 2.1 into 10 to the power 7 Newton per coulomb. So there is this graph and there is this diagram. You can see the electric field's direction. Electric field line is moving downwards. Electric field always moves from the positive to the negative charged plate. Now you can see this oil droplet is balanced in this electric field. That means the weight of this oil droplet is balanced by the force of the electric field strength. Now, since the force of the electric field is upwards, this oil drop should be attracted to this positive plate. If it's getting attracted to the positive plate, it's obvious the oil droplet is negative charge because unlike charges attract each other. Now the question is, the weight of the droplet is exactly balanced by the electric force on the droplet. What is the charge on the droplet? In order to find the answer to this question, you need to equate this weight by the force due to the electric field. So I have done this one is force due to the weight. In other words, you can write weight. As they say, it is exactly balanced. It is force due to the electric field, which is, as you know, electric field strength is equal to force per unit charge. So force is equal to EQ. The mass is given as 6.9 into 10 to the power minus 13 for the oil drop. G is 9.81. Then to get the value of charge, you have to divide it by the electric field strength, which is already given as 2.1 into 10 to the power 7. Once we simplify, the charge becomes 3.2 into 10 to the power minus 19 coulomb. But we already found the oil drop is negative because it is getting attracted to the upper positive charged plate. The charge will be negative 3.2 into 10 to the power minus 19 coulomb. When you check this option, your answer for this question is option D. Question 13. The diagram shows 4 forces applied to a circular object. So there you can see there are 4 forces acting on this circular object. Which of the following describes the resultant force and resultant torque on the object? Now first let's check whether this circular object has a resultant force. Now we know that there is a 30 Newton towards the right and also there is a 30 Newton towards the right. So in total we have 60 Newton towards right, but we do not have any force acting towards left. So there is a resultant force horizontally. Vertically you can see upwards there is 45 Newton, downwards there is 45 Newton. So vertically it is balanced. However, the resultant force in general is non-zero. So your answer will be either A or B. To find the resultant torque, we have to find whether the turning effect, that is the moment of force, is 0 or not. From here, let's take this center as the pivot. So if I take this line, this 30 Newton is moving clockwise, this 30 Newton moving anti-clockwise, and they are kept at the same distance from the center because the circle has a radius, constant radius throughout. As a result, this 30 Newton clockwise and 30 Newton anti-clockwise will cancel the turning effect. As a result, there is no moment due to 30 Newton. However, if you consider this 45 Newton is moving towards the clockwise direction. This 45 Newton is also moving towards the clockwise direction. So there is a 45 Newton in both the side moving towards the clockwise direction. As a result, the turning effect is not cancelled. So the resultant torque is also non-zero. Therefore, the answer for this question is option A. Question 14. A mass at X inside a uniform gravitational field experiences a gravitational force of 0.200 Newton. It has 1.00 joule of gravitational potential energy. Okay, so at this point, there is a gravitational force of 0.200 Newton, but the potential energy at X is 1.00 joule. The mass is then moved to a point Y. From X, they are moving to the point Y. What is its new gravitational potential energy? In order to make things simple, let's consider this side as the Earth's surface. Now at this point, we have 1.00 joule. Now when it's moved away from the Earth's surface, the gravitational potential energy increases. At the surface of the Earth, at this point, the gravitational potential is 0. When it is moved upward, your gravitational potential energy increases. Now, in order to find the gravitational potential energy at Y, we need to sum the gravitational potential energy at X plus the gravitational potential energy, the gain in the gravitational potential energy to move 30 centimeter above this point X. Remember, we should always take the length that is parallel to the gravitational field. So you're not supposed to take 50 centimeter, you will be taking 30 centimeter as the gain in the height. So gravitational potential energy at Y is equal to gravitational potential energy at X plus gain in the gravitational potential energy from X to Y. So already we know the gravitational potential energy at X is given as 1.0 joule plus gain in the gravitational potential energy. The formula is mgh. Mg stands for weight, which is already given as 0.200 into the height. Height should be always parallel to the gravitational field, so we are considering 30 centimeter. Since it's given in centimeter, converting to the SI unit of length, which is meter. So converting centimeter to meter, 10 to the power minus 2. When you simplify, the answer becomes 1.06. So the answer for this question is option C. Question 15. A small mass is placed at point P on the inside surface of a smooth hemisphere. So when they mention the word smooth, it means there is no friction. It is then released from rest. So now at this point P, it is going to be released from rest. That means the initial speed at P is 0. When it reaches the lowest point, its speed is 4.0 meter per second. So when you reach this point, it becomes 4.0 meter per second. The diagram, not to scale, shows the speed of the mass at other points Q, R and S as it slides down. Air resistance is negligible. The mass loses potential energy E in falling from P to T. So the loss of potential from P to T is considered E. At which point has the mass lost potential E by 4? So we need to find whether it is the point Q or R or S, which point there is a loss in the potential quarter of this value. Now to make things simple, I've written it here. At point P, the potential energy is maximum and there is no kinetic energy. Why? Because the speed is 0. Now once it moves from P to T, the entire potential energy is being converted to kinetic energy. Why? Because T is the lowest point. So that's why it's written here. At P, potential energy is maximum, kinetic energy is 0 as it is at rest. So potential energy lost at T is going to be the gain in the kinetic energy at T. Now the maximum potential energy or the loss in the potential energy E, in other words, it is the gain in the kinetic energy at T. So this is the first thing. So completely the potential energy is lost at T, which means if it's lost according to the conservation of energy, kinetic energy is gained at T. So that's going to be half. Let me consider the mass of the small object as m. the lost in the kinetic energy, so the entire velocity at the moment at t is 4. Half m 4 square becomes 8m. Now this is the value of your E. Now we need to find the energy lost, which is E by 4. So E by 4 means energy 8m divided by 4, which is 2m. So we need to find at which point there is a gain in the kinetic energy by this amount, 2m, or loss in the potential energy of 2m. So let's check Q. Potential energy lost at this point Q is going to be the kinetic energy gained at Q. Half m, the speed at Q is 1, so 1 square. So when you simplify, you get 0.5m, which is not 2m. So Q is not the answer. So option A is not the answer. Potential energy lost at R, which is similar to the kinetic energy gained at R. The speed at R is 2, so half m 2 square. When you simplify, the answer is 2m, which is 1/4 of your E. So this is the answer. The point is R, but it's okay. Let's continue checking for S. So potential energy lost at S, which is gained kinetic energy at S. So the speed is 3. So half m 3 square, which becomes 4.5 m. Remember, the m does not stand for the unit of length. It stands for the mass of small object. Since we don't know the mass, I've mentioned it as m. So again, S is not the answer. None of these are the answer. That is incorrect because R is the point where the energy lost, potential energy lost by E by 4 is applicable. Therefore, the answer for this option is B. An escalator is 60 meters long and lifts passenger through a vertical height of 30 meters as shown. So this is a 60 meter long escalator, 30 meter height. To drive the escalator against the force of friction when there are no passengers requires a power of 2.0 kilowatt. Now this is to drive. The escalator needs 2.0 kilowatt to drive against the force of friction. The escalator used by passenger of average mass 60 kg and the power to overcome the friction remains constant. So the same power will be applicable for any passengers, any number of passengers. How much power is required to drive the escalator when it is carrying 20 passengers and is traveling at 0.75 meter per second? So in this case, we need to find the amount of power required when the escalator is moving with a speed of 0.75 meter per second with 20 passengers. Now you can see they have given a constant speed, which means acceleration is 0, resultant force is 0. So the forward force will be equivalent to the friction, which is the opposing force, plus the component of the weight along the slide. So for example, you can observe this diagram. This is a slant where there is an object moving forward by a force F. Now there is weight acting vertically downwards. Weight will have two components. One will be along the surface. The other one will be on the opposite direction. So if this is theta, this is theta as well. So along this direction, it's going to be mg cos theta. Along this slant, it's going to be mg sin theta. Since it's moving upwards, if there is friction, if it's a rough surface, you'll have friction here. And there is this reaction force. Now, in order to have a constant speed or zero acceleration. That means the resultant force is zero. The forward force should be equivalent to the friction plus mg sine theta. Now we need to find the power. In order to find the power, we need to know the value of the sine theta here. Let's consider this part as theta. You can use this formula. Sine theta is equal to opposite by hypotenuse. So here the opposite is this side, which is 30 meter, and hypotenuse is 60 meters. So sine theta will be 0.5. Next is we have to find power. Power is equal to energy over time. So in this case, this is the force. Force into the distance divided by time will give you the energy for this part, plus power required to overcome this friction is given as 2.0 kilowatt. Now T over T, that means distance over time, is the speed. So this whole part is speed. M, the mass of 20 passengers. 60 kg is per passenger, so 60 into 20, that's the mass. To convert to weight, you have to multiply by g, which is 9.81. Sine theta is 0.5 and velocity is speed is given as 0.75. Plus this value, when you simplify, your answer is 6.4 kilowatt, which is your option B. If you find this video useful, like this video, subscribe to Learners Club and press the bell button to get notified with new videos. See you in part 3. Bye-bye.